All right. Thank you all for coming. My name is Ruckus Voxi. I'm a senior developer advocate. And these are dancing reindeer. Aren't they cute? I want to see that again. Hold on. Dancing reindeer. And the reason for these dancing reindeer is they are going to help me show you how to approach platform engineering by building robust CLI tooling just for the cars with keeping 12-factor app principles in mind. And I'm going to do that by showing you basically this a CLI tool to demonstrate the robustness. When I say robust, I'm talking about something capable of producing and then afterwards managing something like this. An entire Kubernetes-based internal developer platform, or IDP, as we like to shorten things, consisting of all of the open source CNCF projects stitched together as needed to complete an entire end-to-end production environment. And the code for this, of what I'm going to show you today, which includes those dancing reindeer, of course, as well as the example of the more production-oriented tool that I wrote around that big ol' IDP thing, you can find at this QR code. And if you didn't scan it now and you want it later, just come find me. I'm around. So let's talk about the 12 factors. And for those of you who don't know what this came out in 2011 by engineers at Heroku as a methodology to take what was happening at the time with these monolithic apps that were written for very specific hardware as a way to break that up and decouple it from the environment so that they could scale as more modular components. Sounds familiar, right? This predates the paradigm of cloud native and was a huge part, actually, in shaping that. And then for those of you who do know what this is already, y'all often roll your eyes at me when I bring this up. Yes, we know about the 12 factors. It's been like, what, 15 years? And I agree. And I do agree that these are essentially so baked in at this point. We're doing this a lot of the time without even thinking about it. But a lot of the time is not the same as all the time. We've all seen it. You come across a code base that makes you go, ah, no, why did you do that? You know what I'm talking about. These happen, and some more recent than others. Additionally, we now have this era of vibe coding, which not all, but some people are maybe doing a little more copying pasting, which is different than taking a very methodical, intentional approach to how you are going to scale this and maintain it and set yourself up for success. So this is all to say that maybe these aren't always as baked in as we think. And in a perfect world, we do something like this, where we check every single one of those boxes. But we don't live in a perfect world. There are always some nonsense, some ridiculous things that we have to work around. So it's okay to be imperfect. It can look like this, or like this, or perhaps there's a couple of them because maybe the thing that you're building actually not all of them are applicable. Like a stateless CLI tool, I'm not going to go to the end of the earth and back to figure out how to make it fit the mold for port binding if it doesn't need it. And then you get situations like this where maybe person A says yeah, and person B says nah, and person C is like, I don't know and I don't care, but it works. And that's okay too. The point I'm trying to make with this is that I don't believe you should be overly rigid or dogmatic about any one particular framework or principles or paradigm or any of that. Because again, the world is not perfect. We have to work around things. So this is just something that's a good reminder, a good checklist to go through, and then as you're developing, something good to come back to once in a while and see how many of these you can check off. So I'm going to demonstrate this by showing you the exact process that I followed for building the CLI tool that wrapped around that IDP thing. And you can pick any programming language of your choice. Most of them have frameworks and whatnot to help produce CLIs. I chose to do mine in Go. So I did go mod init to initiate the project. And then I installed Cobra CLI, which is written for the Go environment, to very, very quickly build out production enterprise grade CLI tools, because it lays out a lot of boilerplate code and the whole project structure for you to already set you off in the right direction. So it really, really speeds things up. And then as a separate dependency, I add Viper. So Viper is completely separate, but integrates very smoothly with Cobra. And Viper is for handling configuration. So this would be like your configuration file or something to retrieve values from environment variables. So I have already run these commands to set this up. So now let's init a new project with Cobra CLI init. I'll add a flag for an author. It has an optional flag for generating a license file for us. And then the tag Viper bootstraps this project with the Viper, with Viper already integrated. And allegedly, it did something here at this file path. Do a quick ls, and it looks like it did. There's a license that wasn't there before, a main.go, as well as this source file under the cmd directory, root.go, which would represent the root command of this CLI. And in the main.go, there's the author and the license. And then we have this entry point function, which is calling from that root.go file. You can see off the bat, it's already imported the Cobra and Viper libraries for us. And under that, there's this struct with some fields where we can define help text for the help menu, both a short description and a longer multi-paragraph one, if we wish. And it's commented out currently, but this run func here is just where you put that logic, what we actually want to do when this command is invoked. And there's that entry point function again, but then under here we have an init function where we can define persistent flags, otherwise known as global flags, meaning they're relevant anywhere in the recursion, as well as local flags that are only relevant to this one command. And it makes complete sense that these would go in the init function, since those fire off before the main body of code. It at least makes sense to me that that's when I would want to parse the values that we're feeding to a command line tool before we do something with it. And then there's one more init one just for the config for the Viper library. And by default, it picked YAML, and it gives a name for what file it's going to look for. In this case, it based it off of my Go module. And then we also tell Viper that it can go search for these values in environment variables. So this is pretty simple, right? This is not very much code. And yet, a lot has happened here already. We have the entire structure for this project already laid out. The ability to add and remove commands and subcommands in a way that is already modular with their own global and local flags, and even a whole help menu already laid out for us. A lot has happened here. And it makes it very, very easy then to then add a new command. So let's check that out. If you run Cobra CLI add and then the name of the command, in this case, I want a command called dance, because I don't know about y'all, but I'm going to see some dancing reindeer up in here. And similar to the root file, it created a dance.go where we can define that command logic. And there is already imported the Cobra library. And then just like the other one, we can define, we have the help text menu and the run function, and then its own init func to define global and local flags. And the syntax here of what you see in those parentheses, that toggle is going to be the long name for the flag, the T for the short name, and if you're looking at the terminal text where it says false, that's going to be the default value, followed by some short help text to accompany this flag when you're looking at it in the help menu. So let's go ahead and pop one in. I defined a flag called duration with a shorthand of TACD, a default integer value of 10, and then that help text is specifying that this is time in seconds for reindeer to dance. And then under that, there's this bind pflags method to Viper, and what this is saying is if I didn't explicitly provide a value to the command, before you provide that default value, go out and see if you can find it in a config file or an environment variable and bind it. Let's clean this up to make it a little more readable. And then again with the run func, where we want to actually put the logic of what happens when this is invoked. So we told Viper to go find a duration value, assign it to a local variable, and then I want to print that value to the screen so we know we're getting what we asked for. And then in this case, just a very simple C-style for loop just to animate the dancing reindeer. Then I'll define some brief help text for the help menu. I'll keep this one simple, dancing reindeer. And then above that, perhaps the most important part, the reindeer themselves. So those are the right-facing reindeer and the left-facing reindeer. And then finally, we'll have to remember to import Viper into this one if we're going to use it, because it was there by default in the root command because we told it to. but it's not going to make assumptions for us that we're going to use it for every single subcommand. Cool. Let's give it a whirl and see if it works. We should already have a help menu laid out for us, and it looks like we do. About halfway down the screen there, under available commands, you see that one that says dance, followed by that help text, dancing reindeer. And like any good CLI tool, every subcommand should have its own sub-help menu, and we do. For dance, again, about halfway down, there is that flag, duration, that takes an integer value, time in seconds for reindeer to dance, with the default of 10. So let's see if the default is working as we would like it to. 10 seconds. A beautiful, lovable, dancing reindeer. And then, allegedly, if we explicitly tell it a different value with that duration flag, we should get that instead. So let's pop that in, and 15 seconds of dancing reindeer. This is so good. I love it. But then remember, there's the Viper part of this, where we should be able to also retrieve this from a configuration file, which complements making it a 12-factor app. So the order of precedence here is going to be whatever you explicitly define on the command line, that's first up. Nothing there, look for environment variable. Nothing there, check configuration file. Nothing there, do the default. So remember, we defined the parameters for that config file in the root command. And if I just pop in a key for duration, I'll give it 5 as a value. And now, let's see what we get. 5 seconds of dancing reindeer. And above, it tells us that it read from that configuration file. So this is looking good so far. But of course, we still need to test out the environment variable. So if I say duration, let's give it 20. And we should get 20 seconds of dancing reindeer. And it still read that configuration file, but it followed the correct order of precedence like we asked it to. This is all complementary to that methodology of the 12-factor app principles. So you can see how flexible and how easy this starts to get over the long run. And off the bat here, we've already satisfied some of these. And we've done like almost nothing at this point. Push it up to a code base, and we've just satisfied another one. Pipe it to a log file, and we've satisfied another one. Like, this is just going great. So then this platform that I showed you, and to be clear, my tool just wraps around this. It deploys it and then can help manage it afterwards via APIs and other things. But this actual deployment comes in the form of a Helm chart, just a really big Helm chart that installs a whole bunch of subcharts. And it's called the App Platform. So the developers of App Platform, they wrote this with 12-factor app principles in mind. They did that when they developed a UI for it and its ability to host its own code databases, its own library of CNCF apps, its own teams or tenants in the Kubernetes model, and within each team their own catalogs of additional Helm charts, build pipelines, Kubernetes services, network and security policies, and their own users. So they did all of this with 12-factor app principles in mind. And what that did was that led them to take this API first approach where they made this 100% API driven. We have a Swagger interface here, which means if we can locate the open API spec for it, and in this case we can, which means we can just copy that and paste it into any file, which means with just a simple config to tell us what we want to do with that, we can have tooling such as the Open API CodeGen tool automatically generate the entire client library for us. If we look at that new file it generated, client.go, if you look there at the bottom of my Vim output, it generated 52,035 lines of code. And again, we've done hardly anything at this point. So now we have this whole client library that we can then just import, or we can add to our CLI tool so that we can make different parts of it importable for different commands that we want to add. So if I go ahead and do that, maybe I want to add a command to add and remove teams to this, or tenants in Kubernetes speak. Again, the same process. Now we have this team.go file that was created. And then I'll import that client library. And then again, we can define some text for the help menu. In this case, add or remove teams from app platform. We can also do some pre-run logic before the run function. And an example of why you might want to do this is because this is using Keycloak for SSO. So we got to get these like just-in-time API tokens if we're going to do some admin task. So really nice that we can go and do that before we actually run the code, because that's got to happen at every single invocation of this command. And then of course the run func, where we put the command logic and where we can import those functions and types and whatnot from that client library. And it's init func, where we can define our global and local flags. Here's one to list teams. I think it probably makes sense to add one that can add teams. And then just to be thorough, how about one that also will remove a team from this instance? And without even looking at that client library that was auto-generated for us, I already know that it can do this. I already know there's functions that exist in it that can do this because it's in the API spec. It's all there. And this is already what we've satisfied just with this very, very brief example. So then as you then go through and you do something like this, where maybe you want to add other commands for other things such as adding users to this, or Helm charts, or enabling other CNCF apps, what have you. You can keep going back to the 12 factors and look at where you're at in the progress there, because we're off to a great start, but that doesn't mean it's too late to screw it up. You can. I've done it before. So it's a good reminder to periodically check back in that and see how many of those you can check in to set yourself up for success. So thanks y'all for letting me ramble about 12 factors and platform engineering and CLI tools, But most of all, thank the dancing reindeer, because they made all of this possible. That's all I got.
Hi, my name is Usman, and I would like to know your take on what do you think about the agentic CLIs, for example, Codex, Gemini, Cloud Code, and since they're non-deterministic, what do you think about them against those CLI as you have built that we know the result that they should provide?
So I'll give you my personal opinion is I'm not the biggest fan because of what you said. They're non-deterministic. This was an example following the Open API spec. We get reliable deterministic results every time. We don't need GPUs for it. We don't need a large model. That happened in sub-millisecond. And so I think a lot of what I'm starting to see, and it'll probably tame down, but using a big model and using those tools to do the same thing, but just not getting those deterministic results. So in my opinion, I think it's good to separate what do we already have in place like this that can give us that deterministic results, and then look where there's holes there, then it maybe makes sense for the agentic tools. That's just my opinion.
Okay, thank you.